I'm looking into very young stars, so stars that have just recently formed. Stars form all the time in the universe. And as a byproduct of star formation, planet formation happens. This is what I'm really interested in, looking at how planets are forming. Now, in the past few decades, we have found that almost every star on the night sky that you can point to probably has some planets orbiting around them. So many thousand planets that we have discovered already. And what we have found is that many of them look very, very different from what we have in our own solar system. And what we would like to understand is why that is the case. Because if we can understand that, then we can sort of figure out how often something like our own solar system happens, and that gives us a bit of an idea how often, say, life happens in the universe. So this is why we are trying to look into very early phases of the formation of these objects. Typical day in Galway, I would come to the office in the morning, and the first thing I typically do is to look what was observed in the night before. This is my favorite part of the day, because these observations, these things that we are looking at, no other human being has ever seen those things. Not even the night astronomers at the telescope would have really seen them, because the raw data that they are taking needs to be heavily processed before you really see the objects that we're interested in. So the first thing I look at is, did anything get observed from the observing programs that I'm currently running? And if I have new data, then that's the first thing I run it through my data processing software that I have on my computer. And it's like Christmas morning every day to me personally. You see these planet-forming disks that I'm observing. They look quite beautiful. Sometimes they have very long spiral arms, they have rings and gaps where you can tell that planets are probably in formation. It's an entire cosmic ballet that you see encoded in these images. I'm entirely hooked to that. So after that, I might contact some of my colleagues from the team that I work with currently. Is mostly in Europe, but I have also some collaborators in the US, in Japan and Australia. So I might contact them if we have found something particular spectacular. Then there's a mental switch happening usually, because I have to prepare classes. Because a big part of my job here is not just doing the research, but also to teach the next generation of researchers. So usually I would have meetings in the morning with my grad students. They are all working on different related observation projects. Then I might prepare a lecture. Typically I have 1 or 2 lectures during the semester that I have running, so something like that. Typically in the afternoon, I would look for observations that need to be prepared, possibly for the following months sometimes ahead, so you kind of try to go ahead with these things. Or I might spend some time actually analyzing the data that I've gotten, so I'm trying to have some research time in the afternoon. There's a lot of reading of the literature involved. Every day in my field there's about 10 or so articles coming out, so you have to keep up with that literature. And there is, when you're going into the data analysis of things, there's a lot of coding involved. So I might sit here, have my headphones on and try to get into a coding space to code up analysis software for the images that I've received. Maths is the key to everything here. It's the language that we speak. If your school offers physics courses, then of course the physics courses are something to concentrate in, because before you become an astronomer, you will become a physicist. When you're looking for places to study, you might look at the physics programs. For example, Galway has a physics program that has specialization streams. One of them is an astronomy specialization that you can start off with right from year 1. But in general, you will first become a general physicist. So any physics program in principle in the country at a university level would be ideal. And then the true specialization into astronomy happens typically at the end of that program, when you do your first research project, which is part of pretty much any program. And then further on, as you start maybe looking for a PhD, which is required to become a professional astronomer. You absolutely have to be good at coding these days, I feel. I mean, there's varying degrees of it, because there's varying degrees in the field. I'm an observational astronomer, so I'm actually not coding nearly as much as, say, some of my theoretical colleagues, so theoretical cosmologists or so. They might do a lot more things like that. But it has become an integral part of all studies, because you have very specialized needs for data analysis, and that's just not something that anyone would provide standard software for typically. So you end up writing a lot of that stuff yourself.